Hello guys, in this video we are going to see how we can create 3D meshes using a video input. So this is the GitHub repository for Neuralangelo, and in which they have shown the steps how we can set it up. So I'm using a Windows machine with RTX 4090 GPU which has 24 gigs of VRAM, and now we are going to see like how exactly we can set up Neuralangelo in Windows system. So here they have mentioned that we can use two Docker files. One is for call map and other is for Neuralangelo pipeline for running the pipeline. So similarly, so right now like I have already downloaded the Neuralangelo Docker machine and also the call map container which was specified in the GitHub repository. And now we will see how we can continue with the data preparation pipeline which they have mentioned. For that we'll be opening this readme MD file link, in which they have like specified the steps which we need to execute. So just for to make it easy, I have copied all the commands in one single file, which will be copy pasting to see. So first of all, I'm going to run the call map container in the Docker. So for this, like I'll just copy paste this command, and here also you can see that I have done a volume mapping from the Neuralangelo repository into the apps folder, and also there's a data volume which I'll be telling you later why I've done this. So I'll just copy paste this command. So using this command I'll be able to run a container, call map container, which is now running, and now we have to run pre-processing step which is specified here. So for this we would be requiring a video sequence. So they have given a sample Lego MP4 file which you guys can download and put it in a folder. So I've already downloaded this video file and kept it in my home directory, parent folder. So we will be running the pre-processing step on this MP4 file. For this you need to specify some environment variables, and then we have to like run this command which will do the pre-processing. So I'll just copy paste this command into the Docker machine. And also here you can see that it is running this pre-processing script, and this pre-processing script is present in the project folder, of which we have already done the volume mapping. So we will be going to the, before running this command, we will go into the app folder and then Neuralangelo. And here we can see there is this project folder from which we can run this pre-processing sh script. So now I'll copy paste this command into the terminal, hit enter. And now it will be like doing the pre-processing from the video file. It will be extracting the images out of it so that it can be used with the Neuralangelo pipeline, which will be part of the next step. So it will also create a call map file for the video which is given as an input, which is Lego MP4 file. The pre-processing, as you can see, the process has been now started. Once this process is completed, it will create the folder Lego DS2, and inside that you can find all the output file of this pre-processing step. So we can already see some raw images have been created here. Now our pre-processing step is completed. Now we are going to visualize the output of the call map file. For that we are going to run the second container, which is for Neuralangelo pipeline. I'll just copy paste this command. And also before that we see we have to copy the call map scripts to the data volume so that it can be shared with the second container. So I've already copied that, but I'll show you the results. So if you do data volume scripts, so we already see we have the scripts present which were there in the call map scripts. So if I do call map scripts, so this content has been already copied to data volume so that it can be shared with the second container. And now I'm going to spawn the second container. And in this we can already see we have already done a volume mapping of the Neuralangelo GitHub repo and also the data volume in which scripts are present. So now we are going to run the Jupyter notebook to visualize the call map, and I'll just show you where that script is present. So if we go to project folder, Neuralangelo, scripts. So here is this visualize call map file. So we are going to run a Jupyter notebook using which we can run this visualize call map file. So I'll go into the app directory, Neuralangelo, and here we are going to run the Jupyter notebook. So our Jupyter notebook is running on the port 8888, which is already been exposed. And here we can see visualize call map notebook. We are going to open, and it is also going to require a token. So I'll just copy paste the token over here. So now we see the content of that visualize call map Jupyter notebook file, and now we are going to run this. We can also see that third-party call map contains the script, which is in which we have the scripts of call map. So because of that, we are able to import this third-party call map script in our Python. And also here you can see the call map path which we are going to visualize. So the pre-process step creates output in this directory which we are going to visualize. Now there are two ways to visualize. One is using Plotly and another is using K3D. We are going to go with the K3D method. So I'm going to run this. And now we can see we can visualize the output. So there is like a sphere in which we can see there's a 3D model present in form of a point cloud. And also like we can see different camera locations around that 3D object, which is like created by the call map. So if you are like getting this output, it means the pre-processing step has been correctly completed because there is like a globe thing and inside that 3D model is present. So visualization step is now completed. Now we are going to use the output which is created by the call map directly in our Neuralangelo pipeline. And now since our visualization part is completed, we are going to use the output of the call map to give it as an input to the Neuralangelo pipeline and train our model. So we are going to run this train.py file. Going back to our Visual Studio Code, so this command we have already run, and now we are going to train the network. So for this I am going to attach a shell to the Neuralangelo container, and we are going to run this command after going to the directory in which this repository is present, which is app Neuralangelo, and then I will run this command. And here you can see it is using like a config file which is Lego YAML, which we can also see here. Going to Neuralangelo configs, Neuralangelo, where is that? Projects, Neuralangelo, config, custom, Lego YAML. So here we can see there are different configuration present, image file and all. And also there is this base configuration in which you can see how many total number of iterations after which the checkpoint will be saved. And also there are other configurations regarding the batch size and all. So if you are having like a low-end GPU, you can configure this file to accommodate the model easily. And yeah, so now I'm going to run this command to train the network and generate the checkpoint. So the training has now been started and it will take like some time to complete the training process, and it has created like a new folder example name in which like you will find the checkpoint file once it is completed. So once this training is completed, like it is going to take some time. So for you guys, like I've created already a backup file, and here you can see there is this PT file, which is the this PT file which is the model checkpoint. So I'll close the training process and we'll move to the next step directly. So the next step is for extracting the mesh. So also in the GitHub repository, if we see ISO surface extraction, so it is to like extract the surface, and if we give this textured parameter, it will also include the textures on top of meshes. So for that, what all you need to do is like you have to specify the checkpoint path, which is this one, which will be actually created in the folder, but I have named it as like backup. So yeah, then the output mesh path, which is this output mesh will be like generated, and then there are like other config YAML, resolution and all, and then there is this extract mesh file, which you can find in the scripts folder. Scripts. Yeah, extract mesh. So we are going to extract the mesh using this command. So what I'm going to do, I'm just going to delete this folder which was incompleted, and you can see like the old textured file, PLY file which was created. I'll just delete it so that we can create a new one. I'll just copy this So as we see, the process of extracting the mesh is now running. It will take around 4 minutes to complete the process. Our texture and mesh extraction process is now completed, and as you can see, there's a new file created, a PLY file. And to visualize this PLY file, we are going to use an online 3D viewer which is available. 3D PLY viewer. So I'm just going to get this file and upload it into the online viewer. So here we can see there's this 3D model which we got from the input video, and we are able to create this 3D mesh using the video which we gave as the input. And the quality that we see in this 3D model is not very good because we trained it up to only 20,000 iteration. But if we increase the number of iteration, the output of this 3D model is definitely going to improve, and we can see like a higher resolution of this 3D model which will be there if we like train it for a longer time.